Hey guys, I was just working on an installment of my vintage TV alignment series where I was talking about equipment that you can use, and I was trying to show off this lovely Wavetek 1080, and when I went to turn it on, it didn't turn on properly. These displays, these are VFDs, they should be lit up, and it's just not working right. I've had trouble with this in the past where it's flaky. In fact, the first time I turned it on yesterday, it worked. Today it doesn't work. I'm kind of fed up with it. I'd like to use it as my main sweep generator, but I have to make it more reliable. So let's pop it open. There we go. Sides come off. Wow. I guess I never did look inside of this. I must have been thinking of something else. That's pretty trippy. There's a lot of stuff in here. We definitely have a lot of integrated circuits. Some of them are socketed. We have a whole mess of connectors all over the place. So this looks like a whole lot of interface stuff. But there's some op amps, some comparators, TLO82, CA339, digital analog converter, DEC 08. Some glue logic, some flip-flops. Wow, it actually is an Intersil 7107. Two of them. They drive the displays using 7107s. That's so bizarre. Those are chips you'd find in a multimeter. Those are analog to digital converters with built-in display drivers. So there must be analog signals, like for controlling the frequency and the output level, and they're translating it to the digital, then driving the displays. I thought this had a digital microcontroller controlling everything, and it would drive the displays directly. Wow. We got a vertical board here with a bunch of socketed parts for the controls. And then here are the RF modules in the middle, and power supply on the back. So. Oh wow, the output attenuator, that's pretty wild. That's what this sort of cylinder is here with the two connectors going in. That's the output attenuator. It's a bit daunting. However, I did read online somebody who had a somewhat similar issue, and a couple things. One, apparently if I short, I think it's pin 1 and pin 37 together, that's a test mode, and all the segments should illuminate. But he solved his problem simply by disassembling this, cleaning the connectors, and reassembling it. So that's what I'm going to attempt to do. In particular, I want to get this front panel disengaged. I'm hoping I'll take all the knobs off, but I may have to. Some of them may have set screws, which would be annoying. Or maybe I could just pull this off. See, there's a board on the front here that's connected to this board with some pretty extensive connectors, but the back, that was just held on by some screws. I already took those off. What I want to do is disconnect the front from this board without damaging anything. I may need to get a little implement in there. There's a lot of force on all those. Yeah, it's starting to go. There's a lot of force on all those pins. I already did try wiggling stuff and turning it on. I had exactly the same problem. So it seems to be the only way these displays aren't working is because it's not getting power. Would be my main thought. But let's just do a visual examination of things. It looks super clean inside. It's hard to believe that this is. Wow, 81. Let's look at the date codes. They may have made this for a while. 89. Okay, let's just round it off to 90. So this is 33 years old. That's crazy. There's no dust inside. It looks pristine. Okay, we've got some nasty connectors on the side. Some RF connector and a ribbon cable. Oof. Not sure. You get the RF connector off. Looks like you might need a little wrench. So let me get some tools and take a closer look at that. I'll give you a peek. So up in here we have one dip ribbon cable, another side ribbon cable, and then an RF connector. And then this thing will come apart. Wow, these RF cables aren't even coax, it's actually a bent copper tube. That's stiff tubing there with the signal running through it. It's probably hollow, maybe that's just, or no, it's ground. I was thinking about transmitters with the signals carried in the end with the skin effect. Yeah, boy, I don't know if you can just pull that off, or do you actually need to get a wrench in there and unscrew it? I think you do. I think it's an SMA type connector. Scant info. Apparently, what I printed out, it's missing the last two sections. It should have a schematic and parts list, but it's missing. I'm trying to find it online. I struck out trying to find a schematic online. Maybe I can buy a CD off of eBay. That's the only source I've found. The one that's readily available, the one I printed out, it's missing the last 20 pages or so, which has the schematic and parts list on it. So I did the best I could. I looked up chip data for the 7107, for example, and it seems to have power going to it. As do the 7406 is a little low. It's like 4.6 volts instead of 5. And this has about 10 volts across it. Also spied an 18 volt regulator down, or negative 18 volt regulator down here, and it seems to be okay. I tried shorting out pin 1 to 37 to test. Absolutely nothing happened. Alright, so I just kind of started poking around. I noticed there were a couple electrolytic caps. I think there might be tantalums up here. They're filter caps. 25 volt. I can't quite see the microfarad. There is 0 volts across that. 0 volts across that. So that's what I was thinking. It seems like part of this isn't getting power. It's not easy to see the power supply down in there. It's kind of hidden away. And I can't readily... Oh, look at the bottom of the board. Maybe there are some labels on the board. Let me turn this off and tip it up. That's what I was afraid of. Nothing is labeled. I can't get at that board unless I partially disassemble this, and I partially disassemble this. I can't try powering it up. Oh boy, there's some weirdness. That it's not soldered very well, is it? And that looks kind of crummy. That, I think, is the underside of an electrolytic. So, yeah, visual inspection is kind of my only option at this point. That could just be flux residue. It doesn't necessarily mean anything bad. The capacitor's on the other side, and crud can't go through this, so that doesn't really seem likely that'd be capacitor leakage. The caps look fine from the top. Yeah, what I really need is some test points. I got instructions that say to check for certain voltages, but I don't know where to check for those voltages. Because just as the service info gets interesting, that's where it craps out. Maybe there are test points. Well, see, at TPA, TPB, CD, I don't know if they mean on the schematic, or is it marked on the board somewhere? This power supply is on the other side of the board in this area. I can't get at it with this thing assembled. Oh, by the way, that connector does unscrew. So I did pull out that board and reseat everything, and it made absolutely no difference. You can see the filter caps down in there. I could blindly try replacing stuff. Man, I can see there's another power supply regulator directly underneath that power transformer. It's this guy right here. Utterly, well, no, I shouldn't say that. It's not inaccessible. I can get at it, but I don't know what the part number is. I don't know what the voltage across it should be. But this is the negative regulator. It seems like there should be a positive regulator somewhere, so that's something I can try poking. Otherwise, it's a matter of pulling out the bottom board and just replacing stuff and hoping for the best. Or I think what I'll do is switch to my backup sleep generator, my older one, my less cool one, and try to track down some real service info. Alright, this guy checks out. The 7918, the one that I can get at. Well, I haven't given up yet. So, 7918. I checked that out. I have about negative 26 in, and I get negative 18 out. That's cool. This guy, which I can't see what it is, but it seems like it's probably a 3-terminal regulator. 2 of the pins have the same voltage on it, about plus 24 volts. So like we're going to have a negative 18 volt regulator. There's probably going to be a positive 18 volt regulator. That doesn't seem right. Which could account for not having no voltage in some of the other areas. So I'll try to remove this board. I can see we have 1, 2, 3 screws here holding it to the back. That might be it. It seems like it is not really firmly attached. Oh no, heatsink. From the back. If I take the 3 screws out of the back, I think the power supply will detach. Okay, making some progress. Yeah, that's a 7818, positive 18 volt, 3-terminal regulator, and there's a 5 volt, 7805, positive 5 volt regulator down here. This has about 8 volts in and about 5 volts out. This has about 24 volts in and only about 0.3 volts out. So either it is defective or something is seriously loading it down. This heatsink back plane is getting pretty warm. It's pretty toasty in the middle right here. That still doesn't mean we still could have a defective regulator or something's loading it down. What could be loading it down? Potentially a failed capacitor. Electrolytic, also if this has some tantalum, those have a tendency to short out, and this thing's getting pretty up there in years, so it's a possibility. I think those yellow guys are tantalum, and when they fail, they basically dead short. And we got all these axial guys. So it's a little tricky to get this out. We've got a big power connector, number of ribbon connectors, and the output attenuator is attached to it. I think if I take out these 2 screws, the attenuator will detach. I'll try to work out the rest of the connectors. I probably don't have any of the parts I need on hand to replace this stuff with, so it'll be potentially a little bit of an expensive gamble to just try replacing everything. I do have an ESR tester though, so I can check the capacitors at least. I'll check those filter caps and try to trace out the circuitry. I'd hate to just shotgun all the tantalum caps though. There's a whole lot of them in here. At least I can use my continuity tester and try to track down any capacitors that are attached to the positive 18 volt rail. It might reduce my quest a little bit. It's weird though that I know it's been flaky in the past, but I can't remember exactly how. As best, I have videos where I demo using this from years ago. As best I can remember, I think the displays always came up, but they wouldn't respond to the controls properly. And maybe this time around, because I haven't used this in a few years, maybe when I powered it up earlier today when it was working and then it failed, maybe that was a cap giving up. Well, that wasn't too bad to get out. I feel like a broken record. How many times have I said that now? Just remove 4 screws in this entire RF deck. Not just the attenuator, but all this stuff is on one subassembly. It's just a matter of the power connector and 2 ribbon, well, 3 ribbon dip connectors. I left this one attached because there's a lot of lead length on the cable. So here it is. First my attention jumped to these things, which look horrific. I thought maybe it was a part had blown its guts, but no. Those, I think, are supposed to be like that. However, it's very obvious that they've been soldered. What are they? I don't know. Perhaps they're two diodes back to back that need to be thermally matched or something like that. I gotta get the schematic if I want to try to figure something like that out. I don't know what I'm looking at. Now the other thing are the regulators. It sure looks to me like the two positive regulators have been replaced. Or it was some really sloppy factory work. So it's the 7805, which does seem to be working, and there's the guy that is not. The insulating bit of mica is very skewed, and soldering job looks a little sloppy. Oh yeah, and the date code, 8931, that matches everything else. Well, 937, if that's 8937. That kind of matches with this too. However, these two, this kind of looks like it's been reworked too. These two are Motorola and this is TI, so they might be replacements. Nothing visually jumps out at me as far as the caps go. So, positive regulators. Leftmost is the input, middle is center. Sorry, the center is ground, and the far right is the output. So I'm going to check the output and see what it's going to. There goes to a bunch of stuff. I thought maybe it would go to one of these big electrolytics, but no. Maybe there was a filter on the output. So it's going over to some resistors. Another resistor. And feed through our via and another via. And then over to these two guys. Huh. I thought it was going to be going to like a power distribution rail, and it kind of doesn't seem to be. I removed the regulator, put a 1K load on the output, hook it up to a variable DC power supply set to 26 volts, and I have my voltmeter attached to the output of the regulator. So here we go. About 28 volts in and 17.76 out. So it sure looks like the problem is going to be something that is shorted on this board. I did start tracing things out. It does connect to this capacitor on this board, so I can check that, and it does go to some of these connectors. I don't think it goes to any of these pins, but it goes to, I believe, a pin on this guy, and it goes to this chip and to this, which is a voltage reference. I'll check that cap, but after that I'm going to wait till I get a schematic. It's going to be too difficult if I have to check for shorts somewhere in this stuff. Well, let me catch you guys up. It's been a crazy 24 hours. So, without any test info, I did what I could. I identified 3 voltage regulators on the bottom board, the power supply board. A 7818, positive 18 volt regulator, 7805, positive 5 volt regulator, and a 7918, a negative 18 volt regulator. Well, with the thing turned on, I poked around and found that the 5 volt was okay. The negative was a bit high, and the positive 18 was like 0.3 volts. I thought, okay, aha, maybe that regulator's bad. I don't have any spares, so what I did is I removed it from this entirely and rigged it up with, and put 25 volts in, put a dummy load on it, tested just fine. Put it back in. Meanwhile, I was trying to find service info. And the scans that are available online, as I think I mentioned earlier, don't have the last sections with the parts list and schematic. I found a guy selling it, bought a copy, didn't hear anything. Sent a couple of emails asking, hey, my payment went through, what's going on? Because it was supposed to be an immediate PDF download. Well, I posted on Facebook, was informed that he passed away. And his wife, I guess, is struggling to get the business up and running. Okay, I reached out to a friend on Facebook, and he knew a guy who hooked me up with the entire Wavetek archive. So I got it. Unfortunately, the scans are not so great. Some of the printouts are kind of illegible, but it got me on the right track. Then I had a fun little adventure. Let's see if I can find the regulator page. Some of these I did screen grabs and enhanced the resolution so I could read the damn things. Here we go. So here are those 3 regulators. A little hard to read, but the one on top, that's a 7818. 1 is the input, and they show 3 going through a resistor to ground, and 2 is the output. Okay, I've been using 78XX regulators for 35, 40 years, and it's always been 1 is the input, 2 is the ground, 3 is the output. Thought, what the heck, are they using this in some weird mode or something like that? I posted on Facebook again and was informed that, some of the Japanese manufacturers like Fujitsu renumber the pins, so they go 1, 3, 2 instead of 1, 2, 3. I'm like, are you kidding me? Are you kidding me? So I was testing it right. And yeah, when you hook it up to the main board, the supply voltages go to crap. Man, it is hard to decipher this, as I said, but if you squint, let's see, there's the block diagram. This guy. You probably can't read that at all, but those 10 little pads there, those are test points. Capital A, B, C, D, E, lowercase a, B, C, D, E. The lowercase are all grounded, connected together. The uppercase are test points for the 5 voltages, and it turns out to be these pads here. So we should have +5, +10, -10, +18, -18. When I power this up, I see the same issues here that I saw when I probed the power supply directly. Okay, cool. I also determined that this cable runs power up to that. So I pulled this out, powered it up, probed around on that without the main board connected, and hey, what do you know? Here I got my -18, +18, +10, -10, 5, all pretty much dead on. The 5 is a little low, but the others, that +10, that comes off of a voltage reference on the main board. Those are supposed to be pretty darn precise for this to work right. It was like 9.999. So those are good when this board is not connected. Okay, there's 3 boards, so I left this connected and pulled off the front board, which has the displays and a bunch of chips on it, going to all these controls down here. There's a bunch of glue logic. That made no difference. So it really seems the problem is on this board. Okay, cool. I have no hope of troubleshooting this board. I let it run for a while, nothing was getting warm. So, I mean, yeah, okay, the chips are socketed. I could just blindly start replacing chips. I already lifted the leg on the 2 tantalum caps. They test fine. I could just replace them, hope for the best. These 0.05 100 volt ceramic caps, it's extremely unlikely those would be bad. 0.22 microfarad 200 volt film caps, extremely unlikely they would be bad. Likewise with these guys. And then there's a bunch of transistors. You know, if something was getting warm, I could zoom in on that. I don't want to particularly spend however many dollars it would take to get replacement chips. I don't have any of these. And just start swapping them out and hope magically that something would start working. But there is another option. So I was really hoping the problem would be on the power supply because it has caps. It has a bunch of tantalum caps. Those guys Now I could just blindly replace all those and hope for the best. Maybe I will. But there is one more thing I can do. I can disconnect this cable. So I have my power supply powered up with no load, where I have my good voltages, and apply dummy loads. It'd be pretty easy because I have a, pull this cable off, I have a dip socket. I can just stick resistor leads in there. Now this thing doesn't draw a whole lot of current, even though there's a whole bunch of chips. They're all pretty low power. So I don't think I need to put too heavy a load. So I can start with like a 1 kilo ohm load on each of those supplies. Because what I'm thinking is, okay with virtually no load, with no load or a very, very light load, maybe everything looks fine. But maybe with a heavier load, things start crapping out. Like maybe there are problems with the bridge rectifier or the filter caps, and or even the some of the other regulators. So the way this works is, let's see if it's, I have a printout showing that. So the plus minus 18, that's simple enough. And the plus 5, they're just brute force, bridge rectifier, 3 terminal regulators, no big deal. For some reason they throw in a 330 ohm resistor to ground. Okay, they put some protection diodes on the output. Okay, but the plus minus 10, that comes from this. So they have a very precise 10 volt voltage reference. And that feeds a good old classic Jelly Bean 4558 dual op amp. And there's where your plus minus rails go. Now an op amp like this cannot supply very much current at all. If there were external pass resistors, yeah, but there don't appear to be, so this can't be supplying more than a few milliamps of current. So I think the problem is really on this guy, because this guy feeds this guy. That's kind of curious. Where does the minus 10 come from? This is going plus 18 to ground, and we get a plus 10 volt reference. Oh, I see. This IC is powered from plus 18, minus 18. So there could be a problem with the minus as well. But the boy, I should really check this too. Well, no, sorry. When I attach the load, yeah, this point goes to crap. It goes like 0.3 volts. So. But what's interesting is when there's a load and this goes to 0.3 volts, I still have like 25 volts over here. Now I did take this out and I put a load of like 100 ohms on it, so it was a fairly heavy load, and it performed just fine. Well, maybe this guy's bad. No, but when I connect that, when I connect the main board and everything goes haywire, this output goes to about minus 19.5 volts. But when things are balanced and if one side's wrong, what would it do to the other side? I don't know. Now if you're wondering what do these connect to, that's annoying. It's on a different page, but rectifier. So they have one dedicated for the 5 volt, just a half-wave rectifier, a big old filter cap. And then here we got our full bridge rectifier, center tap ground, bridge rectifier plus minus, a couple filter caps. And that feeds into this board. Now we do have an op amp here. Oh, and the plus minus, is that a different? I see one. It's a different IC than this. So what are these guys doing? Oh, is this plus minus 10 just feeding back into this to control these regulators to make it the plus minus 18 more precise? Huh. Interesting. Interesting. In which case, I should check all this stuff. So that 10 microfarad, 10 microfarad, 10 microfarad, those are all the tantalum caps, and these two 10 microfarads. So we got 5 tantalum caps. What do I care about tantalum caps? They have a habit of going dead short when they go bad. Unlike electrolytics, which get leaky or go open or dry out, these old type tantalums, they just go dead short. So that's why it's a real simple thing, just immediately blame them. I don't have any. I have 10 microfarad conventional electrolytics, which I could sub temporarily. But I should also check all these resistors. And 4555. I don't have any on hand, but I sure have in the past, and they cost nothing. Like 10-cent parts, so I could dig up some. I mean, if it comes down to it and I have nothing else to lose, I'll just order up things I'm suspicious of. I'll order up all new tantalum caps. I'll get some new 4558s and whatever other parts I think. It's annoying because I just ordered a bunch of parts from Mauser last week before I knew this thing had died. That little can there, that's the 10-volt reference there. And there's a trimmer for it. So all the stuff I was just talking about, it's all right here. The two 4558s, the 10-volt reference. Oh, I guess some of those caps are, well, the 100 microfarads are electrolytics. The 10 microfarads are all those yellow guys. So that's where I'm at. So let's start out with, I won't put a load on the 10, I'll just put a load on the plus minus 18. With this cable disconnected, I'll put 470 ohm load and see what that gets us. Unfortunately, I have a perfect plus minus 18 volts with dummy loads attached. I was really hoping that was going to be the problem. Back to the main board. Sure, I can spot check all the 300 resistors on there and diodes and transistors. Oh man. Well, interesting development. Hey, we have displays and they respond to controls. Oh, what did I do? I pulled power off of the RF module. Or I shouldn't say power. It still has power. I disconnected, actually I'm not entirely sure what it is, but it's a cable going from the RF module down in the middle of the heart. This is the attenuator, but behind that, it's a metal box. Had a ribbon cable going to the top board into that connector. I pulled it out. So, what exactly is it doing with that cable disconnected? Well, I suspect there's actually no RF output at this point. We just have displays. So I took the plunge. I removed the RF module, which I thought was hermetically sealed, but it turns out just 4 screws. We'll undo a cover and you can get right into it. I forget that this thing is was designed in the early 80s, not like the 2000s, so it's really, there's no surface mount stuff in here. Even though this will go up to 1 gigahertz. So it's actually kind of sort of repairable. Well, right here are the 3 power inputs for plus 5 and plus minus 18. I checked the 3 tantalum caps right there, right across the power supply going to ground, and the one going to the 18 volt bus shows a dead short. So I clipped it out. I don't have this type on hand. It's 1 microfarad 25 volt. But I did have a 4.7 microfarad 25 volt, so I tacked it into place. If this fixes it, I may order up a bunch. If I'm really going to be using this as a workhorse, I'd like it to work reliably, and of course these other 2 are primed to go, and there's a couple more down in there, 1 there, and a more conventional electrolytic over there. Oh, this coil, this is microwave coax that's just shorted out at the end. It's used as part of some kind of stub filter, I think. This is the marker generator side, and this is the sweep generator side. So it's a bit of work, but I'm going to put it all back together and see how it works. And if it does work well or restores functionality, not only might I want to replace those, but all these as well. All tantalum caps are suspect. Now these guys are still made in this style. I think they're pretty darn pricey. Alright, let me get you up to speed. No, it has not been fixed. I have the RF sweep unit still disconnected. So I found 1 shorted cap inside this box. I replaced it. Made no difference. The remaining tantalum caps I checked with an ohm meter, and they seem to be okay. At least I had more than 1 kilo ohm of resistance across each of the other caps. But I clipped them out anyways. After all, they're power supply filter caps. They're not critical to the operation of it. Still wouldn't turn on with this unit connected to power. I was then informed, hey, there are actually some parts on the other side of this, and oh yeah, there's a whole bunch of parts on the other side, including some more tantalum caps. Clipped those out. When I hooked it up, the display went on for a second, then they went out again. When I turned it off and back on, I couldn't replicate it. So perhaps something worked for a moment and then burned out again. I don't know. I'll tell you what I do know is these are really uncommon. If you look at the listing history on eBay, there are none of these. In fact, I got this one, I don't know, what, 10 years ago, something like that. I don't recall ever seeing another one come up for sale. So the odds of me finding another one, a parts unit or something like that, are slim to none. Finding just this RF unit, I think, is even less likely. But what I did do is I went ahead and ordered up new caps for this thing to replace all of these tantalums and the few electrolytics on the power supply board. Cost me about $50, but I figured it's worth a shot. Otherwise, this thing is just useless. Now, as far as the other parts in there, so say a transistor shorted, or there's an op amp in there. There's a 74 LS90 decade counter. Well, that's on the marker side, which seems to be okay. But on the RF amp side, on the back side, there is a 4558, I think, op amp. That could be replaced. The handful of transistors, they're all obsolete. I don't think any of them are made anymore. One or two I can probably still get from DigiKey. Most of the stuff that looks like transistors are actually microwave amps. Also obsolete. So to get those obsolete parts, I would have to gamble on the vintage integrated circuit transistor market, which I've heard is fraught with counterfeits. And they're not cheap. Those microwave units, there's like 5 or 6 of them in here. $20, $50 a pop. For me to just randomly try replacing them thinking it might solve the problem, I'm not going to invest that kind of money. So the caps will be here in a couple days. I'll give it a try. So here's what I'm thinking might possibly be the problem. There's nothing dead shorted in that unit. There's 1K or more of resistance from the power supply rail to ground on both the plus 18, minus 18, plus 5. However, when I apply power to it, maybe a transistor or microwave amp is getting turned on and it's defective and it's drawing too much current. Or it's when that tantalum cap shorted, it damaged something in the power supply and it can't supply enough current and it just goes into shutdown mode. So it's a weird power supply. I did try simulating a load on it with some resistors, but I don't know how much of a current load it's designed to supply. I don't know how much current that RF sweep unit draws. So that's just one speculation I have, that actually the RF unit might be okay, but the power supply is damaged and can't supply enough power to it. Anyways, I'll hook this back up. We'll give it one last try. And then this is going to get shelved for a while. Meantime, I'm going to move on with my backup older Wavetek and proceed to use this guy. Okay, power has been reconnected to the RF unit. Let's see what happens. Nothing. I mean, the displays don't light up. So these light up because the plus 5 volt supply still works, but the plus and minus 18 are just out. Okay, so new caps will be here in a day or 2 or 3, and when I have time, I'll recap it. Meanwhile, if any of you have any thoughts, maybe somebody's got some experience with this unit, I'd love to hear from you. That's all for now.